questions on 6.2, integration by substitution. So this method, what we're trying to do is make it a simple integration like we did in chapter 5. So in chapter 5, when we had something like this, the integration of x plus 2 to the 5th power, you would have to take each of this x plus 2 out in the parentheses and distribute it all out, right? And then you would do a simple integration. Well, to help you to do this at a faster pace, what we're going to do is called a U substitution. Now, if the U substitution does not work, then you have a different method, and that's what we're learning in chapter 6 is all the different methods that do work, okay? So the first thing you want to do is, can you do a simple integration? If you cannot do a simple integration, then you have to do as a U sub. So let's take this as a U sub. Now for the U, it usually will be anything that's inside a parentheses, a bracket, a square root, any of that stuff right there. So all of this right here, the x plus 2 is going to be my U. So this is going to be U is equal to x plus 2. And then we're going to take the derivative. So derivative of U becomes du. Derivative of x is dx. And then derivative of 2 is a constant, so it becomes 0. So we're done with that. Okay? So now let's go ahead and fix this up. So now we have is the integration of all of this right here is your U right there. So I'm going to call it a U instead, to the 5th power, right? Because that does not change. And then the dx right there, I'm going to substitute the dx with the du. So then how do you know what the variable is supposed to be on here? It's supposed to be whatever this is right here, it matches. So if this is a u, it should be a du right there. So if you notice this right here, the variable was an x right here, so that's why you have as a dx. So in your equation, if you have a y, then it should be a dy as your final answer, okay? So here we are at the integration of u to the 5th du, and we like this because now it goes back to chapter 5. It's a simple integration. So the simple integration turns into u to the 6th, right, divided by 6, and then with all integration, we put a plus c unless there are the limits right there. Since there's no limits, we're going to put a plus c. So then from here, I'm going to pull this 6 as 1/6, and then the u, we're going to put that back in, the substitution, as x plus 2 to the 6th power, and then plus c. So that's your final answer right there. That was the integration. So if you take this out right here, right, and then do 5 parentheses, distribute it all out and all that stuff, and take the integration of it, it actually should come out to this part right here. So again, if I take this out to the 6th power right there, each of the parentheses, and distribute it all out, then it would come out to exactly what we just mentioned for this part. But we like to keep things nice and tight, so we have this right here as x plus 2 to the 6th power right there. Okay, let's try the next example. Example 2. So I have is the integration of the square root of 4x minus 1. So again, we as mentioned before, anything that's inside a parentheses, bracket, square root, inside this part right here, most likely that's going to be your u. So let's take that as my u. So u is 4x minus 1. And then from there, I'm taking the derivative. So du is equal to 4, and then the derivative of x is gone, so it becomes dx right there. So this is kind of like that implicit stuff that we did, right? When we take the derivative of the variable, then you make sure you had a d something of that variable right there. And then the minus 1, the derivative of that is 0, so we just leave it that. So we want dx by itself, so we're going to bring the 4 over on the other side. So we're going to divide by 4 on both sides, so it becomes 1/4 du is equal to dx. And now we do the substitution. So we have is the integration. Now the radical right there, I'm going to take it to the exponent instead. So this is, all of this is your u right there, right? So that's my u to the 1/2 power right there. And then dx right there, I'm substituting dx with all of this right here, the 1/4 du. Since 1/4 is a constant, I could pull it up in front of the integration symbol and then du. And again, it matches. This is my u, so this is my du right there. Okay, so remember we had done this in chapter 5 as well. Anything that has a radical, we always want to put it up to the exponent right there, because when we take the integration of an exponent, or when we take the derivative of an exponent, it makes it easier for us. So exponent is your next friend, right? So now we take the integration of this. So I keep my 1/4 integration of this. So it becomes plus 1, which is like a plus 2 over 2. So that becomes u to the 3/2. And then normally we would divide by 3/2, but we learned that in integration chapter 5, the simple integration, it makes it simple if we just multiply by the reciprocal of this coefficient right there. So we go 2/3 instead. And then with all integration, you want to put a plus c right there. Okay, so let's simplify this right here. 2 goes into 4, right? 2, 4, 1. So that's 1/6 right there. And then I'm going to substitute the u back in, so which was the 4x minus 1, minus 1, to the 3/2, and then plus c. So that's your final answer right there. All right, let's try example number 3. Now, on this right here, it gets a little tricky once we start doing the trig ones. This can all be your u right there, but the only problem is if this is my u and I take the derivative, we're going to have to do a chain, so that's going to then require some extra variables and things like that. So we don't want that. We probably want is just this part right here as my u right there. Okay, so let's do that as my u. So u is equal to 7x plus 5. So then du is equal to 7 dx. And then again, the 7, we want to bring it to the other side, so it becomes 1/7. Du is equal to dx. So now I do the substitution part of it. So integration of sine u, right? Because we said all of this is right here was your u. So sine u. And then the 1/7 is a constant, so I can pull it up in the front of the integration symbol, du right there. That looks good because now this is right here is a simple integration right there, right? So remember, if you have sines up here, integration, you go up on integration, so this will be a negative cosine. So it'll be 1/7. And negative, you always pull up in the front because you don't want to make it look like 1/7 minus, right? So just pull up in the front. Cosine of u, and then plus c. And then from there, we just need to substitute in the u again. So cosine, and we said u was 7x plus 5. So we put all of that, 7x plus 5 plus c. That's it right there. Okay, let's try the next one. Example number 4. So example number 4, whenever you have an exponent like this, remember with the derivatives and also for integration, the same rule applies. You always want to pull it up as an exponent outside. So let's do that. So we have a cosine 2x, and we want to pull this outside right here as a 2 right there, dx. Okay, now I have to choose again what is my u. So as what we did in previous example 3, we could choose all of this right here, and we said that's not a good idea because remember when you take the derivative of that, that's going to require chain, and then you're going to have an extra sign or something like that, which we don't want. And so then probably the best bet is this right here, that's your u right there. Okay, so then this is your u, is 2x, so du is equal to 2 dx, right? So we're going to pull the half, or 2 on the other side becomes a half, du equals dx. And now we do the substitution. So it becomes 1 over cosine u, right? Because all of this was right here is u, squared du. But this is a trig identity, right? 1 over cosine squared becomes secant squared. So secant squared u du. And then we could take the integration of secant squared, which is tangent, yes. Oh, I forgot to put the half right here. So let's put the half back in here. Half. Okay, so then half, it becomes tangent u, right? I think I got a little excited with the trig identities there. So then u, we put it back, and we said 2x was my u, so then it becomes half tangent 2x, right? And then plus c. And that's your final answer right there. Okay? All right, now last example, example number 5. So example number 5, we have to choose what is my u. So here are some tricks. If you have this, because both, we said it has to be inside the parentheses, so both of these guys are inside the parentheses. So I have to choose whether this is my u, all of this right here, and then if this is a u, then it should cancel out is this part right here. Or I would have to choose this as my u, and hopefully then this will cancel this out right here. Okay? So if you remember, when we choose a u, we have to take the derivative of that, and then the derivative is a smaller factor. So your goal is then always, the trick of it is always to choose the bigger one. So this is the bigger one because it has x squared right here. If I choose the derivative of this, it just becomes 1, right? 1 dx. So it's not going to help us cancel this guy out right here. Okay? So let's choose that as my u then. So u is equal to x squared plus 2x minus 3. So then du is equal to 2x, right, plus 2 dx. Again, if you look at this right here, our goal is to hopefully cancel out this right here. But right now, at the moment, it doesn't look like it's going to happen because of the 2's. So let's factor the 2's out. So I have is then 2 x plus 1, right, dx. That looks closer to what we have up here. Okay, so we want dx by itself, so I have to divide both sides by it. So it's 1 over 2 x plus 1 du is equal to dx. So now from here, let's go ahead and do the substitution part of it. So we have is the integration of all of this is your u now, right? Because we said all of this is your u squared. Okay, and then we copy all of this right here, the x plus 1, because I did not touch that part right there. So I have to copy that. Now we take the substitution of dx, and we said dx is going to be this right here. We're going to substitute with all of this right here. So I'm going to do a straight substitution. I'm going to copy all of that right there. 2x plus 1 du right there, right? Because we want the variable of u right there. So can you see now that this is going to cancel each other right here? Beautiful. Cancel, cancel. So then you're left with is a half, and the half is a constant, so we can pull it up in the front of the integration symbol. So half u squared, and then the du back here, so which is du. Can you see that all of this turns into a simple integration? Yay, we like it. So then this is going to be then half u to the third power, right, all over 3, and then plus c. And so this is a multiplication right there, so 1/2 times 1/3 is 1/6. So that's 6, and then we substitute the u back in. So again, the u is all of this right here, so we're substituting all of that in there. So u squared plus 2x minus 3 to the third power, and then plus c right there. Okay, so let me do a quick review on that one again, because that gets a little tricky. So between these two right there, parentheses, we had to choose one, and I would suggest always choosing the bigger one, because then hopefully that bigger one, when you take the derivative, will cancel out the smaller one on the exponents, right? So if we choose this, I took the derivative of it, and when I took the derivative of it, it immediately was not exactly the same. So, but if we factor the two out, then we can make it the x plus 1's the same right there. So we bring all of that over to the other side. Then we do the substitution method. So we substituted all of this right here. We said all of this is your u right there. So that was the u squared, right? So we put the squared here. And then we copy the x plus 1 because we didn't touch that part. And then we substituted the dx part of it with all of this right here. So that was the substitution right there. And now we can try to simplify as much as possible. So we cancel those guys out. The half right there gets pulled up. U to the second, and then du is left over. So this right here goes back to chapter 5, which is the simple integration, which we love. Okay, so this comes with practice, the u substitution, but it'll come as we practice. All right, so let's go ahead and practice this now.